Okay, so today we're here and we're going to be talking with Mrs. Jenkinson, and she is here and she's going to help us work on some math skills that we're going to need for graphing this unit. All right, so Mrs. Jenkinson, would you give me a review on how to find slope? Let's say I have the slope here and I want to figure out the slope from like 2 to 4 on this graph. Okay. How would I do that?
Well, we're going to choose the point 2. Okay, so we're going to choose the point 2, and we're going to decide what's the coordinate of that point. And the coordinate of that point is the x-axis first, so 2, comma, and then where is it on the y-axis? And if we look at it, it's at a 10 on the y-axis. And then we're going to go over and choose 4, between 4, and we're going to find that coordinate point, and that coordinate is 4, 20.
Okay, so could I have used this point at the 3?
We could have.
Okay, but why did you pick the 4?
I chose the 2 and the 4 because they were the easier of the 2 points to decide what the coordinates were. It was right on the grid.
Oh, okay.
So if I was looking at this 3, I'd have to estimate across where it is. So it could have been at 14, it could have been at 15. It looks like it's slightly below 15, but it's just an estimate. So if I know that it crosses exactly on the grid, I can get a better estimate of what the slope of that line is.
Okay, that makes sense.
Okay, so now we're going to go and remember the slope formula. Do you remember what the slope formula is?
I know it's rise over run, but I don't always know what that means.
Right. So rise over run tells us, if we're looking at the graph, what's the rise? Where is it rising? It's rising on the y-axis. And where is it running? Running means you're going across.
Oh, so that's the x-axis.
X-axis.
Okay, so it's y over x?
Y over x, but we have 2 coordinate points.
Yeah.
So we need to find the change in the coordinates. When I find the change of something, what am I doing?
You're subtracting.
I'm subtracting. So I'm going to take either the first or second, it doesn't matter. The formula does say the second point, and I'm going to subtract the first point of the y.
Okay.
And then I'm going to divide that by the change in the x-axis, the change in the x's. So that's the same thing. Take the second point for the x and subtract the first point for the x. And I like to do this. If this is my first point, this is my x1, this is my y1.
Oh, that makes more sense.
This is my x2, because it's the second point, and this is my y2.
Okay. I could take those numbers then, and I could plug those in.
And
that makes much more sense.
Right. So we're just going to go, what's the first y then that I'm going to use?
20.
20. And I'm going to subtract what number?
10.
10. And then we're going to divide by the x's being subtracted.
Okay,
so what number?
4.
4, because it's with the 20.
All right.
So they go top and bottom.
Okay.
And then we're going to subtract what number?
The 2.
The 2. And again, it's in the same point, so it should be top and bottom.
Okay.
And then we're just going to figure out what those numbers are.
So now, if I think back to my order of operations, I learned it as PEMDAS. That would tell me,
excuse my dear Aunt Sally.
Yes. And that would be, I would have to divide first?
No.
Oh.
You're simplifying.
Okay.
And you're solving out. So you always kind of, if you have a fraction bar, you always want to simplify what's on the top of the fraction bar.
Okay.
And then simplify what's in the bottom of the fraction bar first. So PEMDAS, please, inside parentheses. So what I could do is technically I could put these in
parentheses. Okay.
So whatever's on the top, you always have to simplify what's in the fraction bar on top and bottom of the fraction bar before you do the division.
Okay.
So what is 20 minus 10?
That would be our 10.
And what is 4 minus 2?
2.
Yep. And then 10 divided by 2, since we've gotten rid of the subtraction, is now?
That would be 5.
That would be 5.
Okay.
So our slope is 5.
5. And that's just from the 2 to the 4.
Right. So that's just this line here.
All right. Okay, very good. So that's slope. That I remember doing this now. Now, what if I want to find the area underneath, maybe from 2 to 4?
Okay.
Sometimes I need to find the area.
So that's this shape. So we can first figure out if we know what that shape is. So do you know what that shape is? What shape is that making?
No, I don't. I know it has 4 sides, but it's not a square, it's not a rectangle, and it's not a triangle.
Right. But it could be what put together. If we don't know the whole shape, what could it be as pieces?
It could be, I can see a rectangle and a triangle.
This one right here?
Yeah.
And then the top would be the triangle?
The triangle, yeah.
Okay. Rectangle first.
Okay.
Do you remember what the area of a rectangle is? The formula for area of a rectangle.
Nope, but I do know that when we take and we get the area, we get a squared unit.
Right.
So we're taking something times something. I remember that much. That's all I remember, though.
We are taking, well, where can we find it? Where, if you didn't remember a formula, where could you find that formula?
Well, I used to tell everybody to go to their agendas and look it up in their agendas,
And they're not there
but it's
anymore.
not there anymore.
So we go to the internet,
Oh,
right? Since we have our
we have these computers.
And we can go, type in Google or Bing, whatever you use, and you can say, what is the area of a rectangle? And it will tell you that it's B, which is
the base,
and H, which is the
height. So base times height.
So base times height. So we're trying to find the distance or the length between 2 and 4. So how many units? Because from 2 to 4, I could think that it's 4 units, right? Because it's got the 4 on it.
Right.
But it's not, because I only want to know from the 2 to the 4. So how many units is that?
Okay, so that would be 2 units.
2 units. So our area equals 2. And we have to do the same thing for the height. So what is the height of the rectangle only, the purple rectangle?
So just the rectangle. So the height then would be the 10.
Right. I'm glad you did not say 1.
1. I was tempted.
No, because you're looking at the units on the scale of the y-axis, so you're going up 10.
Okay.
So we're going to put a 10 up here. So what's the area there then?
20.
20. And should we label it?
Let's label that.
All right. So what are we going to label it as?
Well, I took the area, so it'd be kilometers, and then times hours, so it'd be kilometers times hours, right?
So how do we write that?
Kilometer, and then with an H after it, or...
HR is what I usually write as my R.
Very good. Very good.
H.
Yeah, that would work.
So that's the area of the rectangle.
Okay.
So now we need to look up, if we don't know, what is the area of a triangle. I should probably put rectangle up here. Right? Rectangle. Okay, so we're looking at this rectangle, or sorry, triangle. And we're gonna, do you guys know the symbol for a triangle?
A triangle.
A triangle.
All right.
So I'm just going to do that. Area of the triangle equals, and we have to do the same thing. We have to find the formula.
Okay.
But without, if you guys don't remember it, well, how do you make a triangle out of a rectangle? What do you do?
You cut it in half.
Cut it in half. So is it the same formula?
It would be a half of it.
It would be half of a rectangle.
Okay.
So now, do we still have the same base?
We would still have the same base. Yep. 2 to 4, so it would be 2.
So it's 1/2 times 2. And then what's that height?
That height is 10 again.
It's still 10. Yep. So then half of 2 times 10. So the 2 times 10 was
20.
And half of 20
is 10.
Is 10. So that's our area. So 10.
And it would be kilometers.
Kilometers. I
Hours.
just put a negative sign in front of that. Sorry.
Wait, no, it's just a positive.
Hours.
Good.
Okay, so now we want the total area. So what do we do to the two numbers to get the total area?
Total means add.
Total means add. So we're going to add them up. So 20 plus 10 equals
30.
30. Kilometer
Hours. Kilometer hours is kind of a weird unit.
It
but
is
that's
a very weird unit.
It is, yeah.
Yeah.
All right. Very good. I think that's all kind of the math skills that we're going to need for this first part of this unit. Yeah. So thank you, Mrs. Jenkinson, for helping us.
Thank you.